Okay, welcome to our next lecture on artificial intelligence system architectures. Today we are going to touch the heart of our course, system architecture design. So when we look at the place of this course in our course outline, we come slowly to operationalization stage and architecture design. Precisely speaking, today I would like to cover a lot of different aspects, so expect many different presentations in separate videos. For some of you, those presentations may be a bit trivial, they are not that technical. These are designed to explain quite difficult aspects of IT architecture to business users. So I think even though you won't find it technical or complex in that nature, you may find it very useful when you try to communicate architecture design to the business user. Moreover, such a high-level overview of a key concept may be also useful for you when designing your systems. So let's start. This is the simplest possible version of the architecture. You have some input, you have some processing, you have some output. You are probably familiar with that concept. Previously, we were speaking about the machine learning pipeline or data science pipeline. So here we had artifact, here we have a component, and once again it results with the artifact. So this is the simplest version. Obviously, as the source of the data, as an input, we might have people or systems. So when we design such architecture, we should carefully identify whether we have here people as sources of data, like for example, your employees who input some invoice data, for example, to the system, or your customers who purchase something. This data may be left consciously, so you just simply type knowing that you input something to data or not. Such a digital trace may be, people may be not aware of leaving such a digital trace as we usually do using our mobiles, for example. Systems are, for example, sensors in manufacturing line or sensors ever in the car. So that may be also, and it is in many cases, a very important input to the system. So we have some inputs. On the other side, we also have some data, so-called data consumers, which may be people or some other systems. Okay, so as you can see, this is a bit more complex architecture. So let's continue. In reality, the situation may be more complex. We may have multiple different sources of data and multiple outputs. Each of them may be either a person or a system. Okay, we can complicate it even further, drilling down into details of what's happening in this transformation stage. In many cases, we need to separate extraction stage from transformation stage, from loading the transformed data into some repositories, which are waiting, ready to be consumed by data consumers. So this is the most typical extract, transform, load architecture. To make it even more complicated, in case we have a lot of data, sometimes it may happen that we do not have enough transformation power to transfer them as they come, so we need to reverse transform and load stages, and after extraction load it to, for example, the data lake, and then transform the loaded data when it's needed. So then we have another option, which is called extract, load, transform. Good. These guys on the right are called data consumers. These guys on the left, data producers. And this is in the middle is called data transformation. It's not by accident that I started with data consumers. When you design your system architecture, I strongly recommend you to start with needs of data consumers, not from possibilities of data producers. It may be a bit subtle for you, but believe me, in reality, it may have huge consequences. That's change. Just to give you the example, imagine that you would like to create a system architecture for HR, human resources management system in your organization. You have two different approaches. First one is to take all the possible systems you have at hand for HR, identify what they can do, and design a very, very complex, which will deliver almost everything, all the functionalities. It will result in with extremely complex system, which probably won't be easy to understand to the final customer and won't satisfy their needs. The opposite option in the architecture design is to start with very important, the most important issues, challenges, problems of the data consumers. So you start with that and then pick up the most important features of data producers, data produced, etc., to fulfill those needs. So once again, my suggestion is always start with data consumers analysis and then construct data producers and data transformation. Okay. But at the end of the day, it looks like that. Ready? So let's continue. This is a data pipeline. In reality, the picture may be even more complex. If you work for a large corporation, a large company, you probably have a lot of legacy systems, a lot of even hundreds of different systems running in the company. So one such a data science pipeline product may be the input to another one. This may be output of this pipeline, may be the input to this one, etc. So when you design, for example, this system, you must be aware of its place in the whole corporate data architecture. So if you work for such a company, it would be good to find some people or projects responsible for so-called data governance to identify the place of your system within such a corpo. So it looks like that. You need to be aware of this because, as you can see, here you have some data producer. So the data producer, you may have for your system two different data producers. That may be one process or system, another process. Okay, so let's continue. Machine learning model may be this transformer within this ETL or ELT transformation stage. So when you look at this transform stage, that may be a simple script which transforms the data written by the programmer, or that may be a machine learning model trained by you as a data scientist or by your team. So here we slightly touch the AI concept in that place. Yes. So what's the machine learning model? It is a kind of the software which reads in some data, processes this data, and generates some output. So this is transformation, whether it's a prediction of the price, whether it's a prediction of customer behavior, whether it's a segmentation, okay, or generative model. Yep. Okay. So having this model requires the model. So in order to create such a model, we need an extra element in our architecture, which is the preparation, training, and evaluation pipeline in our systems. So we're talking about this previously, but this is something new which you should consider also in your system architecture. So as you can see, this design becomes a bit more complex. Nowadays, there is also another interesting fact that we have a lot of large language models, or in more general, multimodal models, which may be and become a very important component in our pipelines, because this is once again a piece of code which takes some data as input, transforms this input and generates some output. So, as you probably know, large language models has its own requirements according to, for example, infrastructure or connections to LLM services provided by different providers, or it can be even hosted by yourself in your own premises or private cloud. So that makes things even more complicated. But still, we are in this transformation stage. Next important aspects we are going to cover in more details, because this is just an introduction lecture, are data producers. There are different types of data producers that may be transaction systems, Internet of Things sensors, some domain systems. These may be databases, data warehouses, data lakes, or external data sources like social media, logs for systems, emails, other documents. So being aware of those different data producers is a very, very important part of important skill or knowledge of the system architect. So that's also be a very important part of your system design activities. What are the data producers we have at hand? The data transformation we already said is extract, transform, load. We'll dive into details in later on, and data consumers, maybe also from the infrastructure point of view, different storage locations, whether they are databases, data warehouses, data lakes, or applications like desktop business intelligence applications, artificial intelligence applications, analytical applications, whatever you have in your portfolio. So that concludes the brief introduction to this architecture design. In our new lectures, we will dive into a bit more into the infrastructure part of that story. Thanks a lot.